the AI was not something just invented recently. Actually, back into the 1950s, the legendary kind of thinker Alan Turing already proposed the idea, can machines think? So this paper essay was published in the 1950s. Other than just like being philosophical, Turing proposed a very kind of practical way of evaluate whether there are human-like intelligence for machines. So this is well known as a Turing test. The basic concept it is if a machine response are indistinguishable from a human in conversation, then we would consider it has some kind of intelligence. But there is also a kind of contradictory or counter argument on that, like the Chinese box analogy. Like if people just sitting in the box who do not know Chinese but who have all these characters of Chinese and just follow rules to respond, does he really understand Chinese, or who really have the language or linguistic intelligence on that perspective? So there's an interesting kind of discussion and dialogues on how we could evaluate AI. But also there's another kind of envision or vision from Alan Turing about machines, like machine should not just follow the rules, but also they should learn from itself. They should learn like a child. If you observe the child who learn from their parents or from their surroundings, they do not just mimicking, they always can kind of adopting other informations and evolve and learning and grow. So that will be also envision of like how AI or how machines should learn in the 1950s. But Alan did not really coin in the definition of the AI until later. Another legendary computer scientist, John McCarthy, defined the AI in 1956. So he has two kind of emphasis on AI. First on the cognitive part, on the science, and then the second is the engineering part, how we could make the machines to think like human beings. So the means of this intelligence is accessed by computer programs. So this is same as right now. So there are two main kind of streams of approaches for building AI. I think since the very beginning. The first approach was rule-based. So the core idea is intelligence can come from manipulating symbols according to the explicit rules, much like mathematical logics or languages. So the example of this kind of system is called expert systems. Another kind of stream of thought is more like derived or inspired by the human brains. So the AI systems, machines can learn by the data itself using kind of a neuron-like network. So these will actually later evolve into the deep neural network. So let's see how the expert system was. That's the first kind of pilot project in the medicines. They actually encoded expert knowledge into thousands of rules. And the strength of them is they're very transparent. They're like the medical textbooks. So the expert systems will rely on a very sophisticated and well-defined if-then logics to assist with the diagnosis, treatment, recommendations, and decision making. So these tools was kind of innovative and very useful in a certain sense, but they also have huge limitations with limited its adaptations in the workplace. First of all, the system is extremely costly to build because it will involve a lot of physicians and the domain expert to define the rules. And it also limited its ability to learn because as long as the rule is defined, it may not be adapting new rules unless there is other human interventions. And also in the certain sense, it will be also very hard to kind of scary. And this leads to another kind of stream of development of AI, which leads to what we so-called machine learning and deep learning. So the machine learning is basically saying the program systems or machines can learn from the data itself. There are many different kind of algorithms how machine learn from the data, but the key part of it is very data heavy. So usually you will require a lot of data for the machine to learn from the patterns. And also there are some kind of black box problems. There are some of the explainable AI or machine learning algorithms, but others like deep learning, when it gets too complicated, it is kind of hard to explain how the machines really make those decisions or predictions. So there are also some kind of generalization gaps when the data collected from one facility or one site may not be kind of generalizable to another site. So this is kind of active research, and even though there are some kind of limitations for both kind of streams, there are some development but not until the 2010s, there are huge kind of heat on AI. This actually will derive from three different major kind of fuels. One is a technical breakthrough for the deep neural network, and then the GPU renovations also lead to the parallel processing of the computational powers for AI and machine learning, especially the current heat of the large language models. And also for medical field, it is important that the EHR systems is the popularity of the EHR systems, where most of the kind of healthcare systems already used the EHR system that will make the data available for machine to learn and to extract and for diagnosis and for its use. Also just draw this little kind of diagrams of showing the kind of up and down cycle for the excitement and disappointment in AI through the history. So as explained, there's the birth of AI, which is in the 50s, and there are early research involving rule-based systems, as also some new early kind of neural network. And then this kind of excitement kind of quiet down a little bit in the late 70s, which lead to kind of some funding costs. But also there's also another wave of heat when some of the expert systems get a little bit commercialized and they have some over problems. Maybe you can kind of see it right now. And then people get quite excited, and then they also kind of calm down a little bit in the late 80s and early 90s. As I mentioned, the later development of the deep learning and the GPU and more data waves pushed the new waves of AI kind of hit for the recent eras. And we don't know whether the trajectories will be always going up, but we hope we will see more of the adaptations of the AI systems in healthcare. This is the history, and let's get into what is right now. This is a quote from the Fei Li, who is the director of the Stanford Human Centered AI.